So there's 1 or 2 chairs left. If someone's got a space next to them, please put their hand up. So if anyone doesn't want to stand, there's 1 or 2 chairs left. Come and grab a chair. Windows talk. This is cool.
Everyone wants to know how to make the Windows pane go away.
Yeah. Show me on the other side. Cool. We're going to get straight into this. For those that are new here, who's here for their first time? I know there's quite a few. Yeah? Right, I didn't know there was that many. Awesome. The format we have a main talk now. We're going to do a section where you can get up and advertise that you're looking for work or that you are looking to hire someone. We do a small job section, get up, say 1 sentence. We'll do the 2 lightning talks. Hopefully they're both here. And then you socialise for the rest of the night, however long you want. We'll get straight into it.
Cool. Alright, hi everybody, my name is Jason, hopefully you can all hear me. I worked for Redify as a consultant. I worked with PowerShell for automating various things in Windows, builds, deployments, system configurations. I have been as long as PowerShell has existed. And I volunteered to talk about PowerShell v4 desired state configuration tonight, primarily as a reason to sit down and learn it myself, and give myself a hard deadline to spend some time with it, work out how it all works, and then share some of that with you. So PowerShell v4 desired state, v4 in general, but the desired state configuration stuff is very new. I was privileged to get a sneak peek of it at the PowerShell Summit back in April, earlier this year. And then it was officially announced at TechEd North America in June. There are a few preview downloads going around for it, for the previous OSs, or current OSs I guess. And about 2 weeks ago, through MSDN and TechNet, Microsoft made the RTM version of Windows Server 2012 R2 and Windows 8.1 available, which has the RTM version of desired state configuration in it. What I've found is that there's a lot of stuff that is a lot of potential, but there's also a lot of stuff that's really poorly documented at the moment, which is no surprise. I think the official release date will be October 18th, so there's still going to be a lot of stuff coming between now and then. I know that hopefully everyone here has an idea about what the point of desired state configuration is. From my point of view, it's the idea of being able to deal with the configuration of presumably a lot more than one systems. You want to do it centrally, you want to do it declaratively, and you want to use this to provision machines, push out required changes, and to keep environments in sync in general. And while I work predominantly in the Windows world, I know the Linux and Unix, or Linux Unix community has enjoyed tools like CF Engine, Puppet and Chef, which have been doing this really well. And they've been slowly growing and improving their Windows support over the years. But every time I go to look at using those tools for Windows, I keep butting up against the problem that these tools are built around the fundamental concept that everything is a file, and typically a text file. Windows doesn't work that way. So Windows, ultimately you might find that various things get serialized down into an XML file somewhere, the registry, some sort of database. But unless you're working via the API, you can't expect any changes you make to necessarily take effect immediately, to be honoured next time when you restart, or even to be supported if you upgrade to a new OS version. The API is the compatibility layer in Windows, and that's what you need to automate. And using text files isn't going to get you there. So I've always struggled to use the existing products, and it looks like DSC is going to provide that model for us. And the reason why it's going to provide that model for us is it's based on PowerShell. So how many people here are familiar with PowerShell? Have heard of it, know what it is? Awesome. How many are competent with it?
Willing to say
Heavily
so.
regret knowing it.
Cool. So, the reason why PowerShell is different from your traditional shells and is going to fit with the automation of Windows well is because Windows is .NET. PowerShell is built on .NET. It's all about the structured data, behaviors, objects in, objects out, which behaviors on those objects. It's a dynamic COM client. It works really well with all the kind of stuff in Windows without any extra effort. This WMI and the CIM stuff is first hand and really well supported in PowerShell. And of course you can do your texty things too, like you do in your other favourite shells, but that's not the point. In PowerShell, something only becomes text when it hits the screen. Up until then, your usual ls, ps, dir commands, you're dealing with objects with rich properties. It's only when you let that fall out to not going anywhere other than the screen that it gets rendered into text and it just looks like a normal command. And for those familiar or not familiar with WMI, it's sort of been Microsoft's Windows management instrumentation thing for far too long. And it's based on various standards. I think it's the DMTF, or Distributed Management Task Force. But it's always been implemented over a binary protocol. Whereas in PowerShell 3, Server 2008 sort of life cycle, they introduced a series of CIM commandlets in PowerShell, which basically take all the WMI stuff and run it using SOAP XML serialization over HTTP, HTTPS. It's become a good step in the right direction for sort of setting all this stuff up. And there's actually some really good articles out there on using it to manage just standard hardware devices to implement the same standards. So, PowerShell has been around for a while. It's the desired state configuration that's new in V4. And basically, you're getting a new set of keywords to give you a domain-specific language for defining your configurations declaratively. Those configurations will then compile into managed object format, which is what WMI has been using for years, and there's another standard, and not necessarily a Microsoft standard, though I'm sure they've extended it in their own way. Those MOF files are then referred to DSC providers or resources, so you can apply configurations to different aspects of your system you want to manage. A set of new commandlets in a desired state configuration module, which enables you to execute these configurations and test them, and the sorts of things you want to do. It introduces a local configuration manager, which is essentially a service. It's not implemented as a service, but it's essentially a service that's present on all machines with PowerShell v4, and it is responsible for handling the implementation of your desired state configuration. There is also a DSC service component, which enables you to set up a central location from which all your machines can pull their configuration from. Normally, it's a push model. And as I said at the beginning, Server 2012 R2 coming out on October 18th. That's when you get the final RTM of this and be able to start using it in production environments. They're not going to do it for Windows 8. You'll have to upgrade to Windows 8.1 to get this stuff. But they are going to make a separate PowerShell v4 desired state package for your Windows 7, 2008 R2, and 2012 R1. And it doesn't work on 32-bit. It's 64-bit. But no one uses 32-bit anymore. So, I mentioned resources. You get, 12 out of the box, and they're your really basic sort of items you're going to want to deal with. And I'll run through them really quickly. The archive, you take a zip file and you unzip it into a location on the server. Environment variables. File can be an individual file or a whole directory of files. Exactly the same as an archive, except they're not zipped up. Group is for local group membership, adding users, defining groups. The log just logs a message during the configuration run. What would the configuration system be if you couldn't log what was happening? The package is for deploying MSIs or, according to the documentation, running a setup.exe. Not really sure what the deal is there. I haven't tried to use it yet. Windows process, it's a process. I don't know why they felt the need to call it a Windows process. Interestingly, that one will run a process with the given arguments if it doesn't find that process running already with those same arguments. It won't wait for it to finish. It won't check its exit code. And if it comes along later and finds that process has ended, it'll run it again, but it won't run doubles. So there's a few situations where that'd be handy, although I imagine a scheduled task or a service or something would be more appropriate. I imagine it'll get used as sort of an ad hoc way to just run a tool that doesn't have native DSC support yet. Registry keys. Windows features is basically all your Windows roles and features, installing the .NET framework, installing IIS, installing DHCP server, all that sort of stuff. The script resource is probably where you might spend a little bit of time early on. It just enables you to run an arbitrary block of PowerShell script to implement something that it doesn't already have a resource existing for it. Services for Windows services. You can configure them. You can't. It doesn't let you specify the binary that the service will be running as, so it's no good for installing services. It's just useful for configuring the ones already there. And the user is for defining local user accounts. The local user account actually introduces an interesting aspect of DSC right now. When you create a user account, typically you're going to specify an initial password. And at the moment, those passwords get dealt with in plain text.
Hooray!
Yeah. But on the upside, by default, it won't let you do that. It says, sorry, you can't put plain text in here, go away. And you have to explicitly say, no, really, I really want to do plain text. But then that just propagates throughout the system. There is rumour that there are some configuration settings, which I've seen, that allow you to set up certificates to deal with password encryption, but there's no examples of how to use any of that yet. As I said, early days.
Configuring network, where would it be, for example?
Sorry?
Configuring network interface.
So, it doesn't exist yet as a resource. You'll probably start off with a script resource to define that, and I'll get to a few slides a bit later on about custom resources and how that evolves. Cool. So I think that's kind of the building blocks so far. You've got the new DSL, you've got the resources, you've got the configuration stuff. So the next thing is just a really basic, hopefully that's a big enough font because it's PowerPoint, I'm not going to be able to change it that quickly, I don't think. But this is a really simple example of a configuration to install the Telnet client, or actually not to install the Telnet client, is to declare that this server, this target server should have the Telnet client there. If it's not there, install it. If it's already there, cool. And so yeah, we've got the new configuration keyword defining the name of this configuration. You can't use hyphens in your configuration names like you can with the rest of your PowerShell functions because it compiles down to MOF, and that's a limitation of the MOF language. You can still have your parameters just like you would in any PowerShell function. Here I just don't care right now. The node, you then specify multiple nodes. The node represents a target server. You can have multiple nodes in your configuration. Here I'm just saying the local machine. And then within that, I'm defining one resource. It's the Windows feature resource. I've given it a name so that I could refer to it elsewhere. It's purely notational. It's got the ensure is present. That's a property that you'll find on pretty much all the resources, and it's usually either ensure this is present or ensure this is absent. So if I wanted to make sure that it wasn't installed in any box, I could flip that around. And the name here happens to be a property that the Windows feature resource expects, and it's the same name of the feature that you would use if you were using the DISM tools or install Windows feature command or anything like that. When you define this and say, put this in a script file and run the script that has this in it, what you get is a command defined called demo config. That command, it has a particular command type of configuration. It'll have any parameters that you define in the param block, and it'll have a few additional parameters as well that they get automatically for doing that configuration. The main one is the path, which is when you run it, you'll tell it where to go and dump the moth file to. By default, we just create a subfolder under the current working directory with the same name as the configuration command itself. It has a configuration data property which enables you to pass in a hash table, which has a particular format I'll demonstrate later, and that then enables you to have various placeholder values inside your configuration, and allows you to separate, defining what a web server would look like versus the list of which machines are your web servers. So they've got a good sort of level of separation there. There's also an instance name property, which I haven't quite worked out what it does yet. Again, not documented. But I got a funny feeling it's something to do with the pool model, which we'll get around to. So as I said, you run the demo config command, maybe you choose not to pass any parameters in, and it will output a folder with a moth file in it. And in this case, this is approximately what the moth file would look like. Sorry, no syntax highlighting. I didn't find a standard moth highlighter. But you can see that pretty much the same components are there. It's decorated as a role resource. The Windows feature resource also gets called a role resource. And they renamed it halfway and didn't rename everything. We've got an ensure is present. The name is the telnet client, and a few other things that got left in there. The source info happens to be, it came from line 6, column 9 within my original configuration, so it's kind of useful to track that back. And that bottom section usually ends up containing bits like who authored it, what computer it was run on, what time. And so what you can see from this is that you don't really need to use PowerShell to generate these moth files. The new v4 DSL makes it a lot easier, and you get all the IntelliSense tab completion. But if you wanted to whip up something that could spit these out, no reason why you couldn't. And this is ultimately the file that gets shipped around to all the various servers that then use that parser to implement the configuration changes. They then go and store this file away for later reference against if they've drifted in the configuration, because someone's looked at the beginning, they should know. Yeah.
What's the documentation like now?
Not bad. Moth's been around for ages, as long as WMI has existed, because you get to use these files to create WMI definitions. And it's part of a DMTF standard, so there's heaps of docker on this stuff. Exactly how various parts of it rise back to how DSC works would be a different story. But you create a PowerShell v4 script, you run it, you get a moth file out, you go, oh, I had no idea the source info had anything to do with the column and line number, but 2 seconds of looking at side by side was, oh yeah, it's not too hard. Hopefully you don't have to deal with them too much, but if you're in a non-Windows world, you can still produce these and archive them, deal with them, different, whatever you need to do. Human readable. So the local configuration manager. This is going to be present on every box with PowerShell v4. So all your Win 7, 2008. And as I said before, it is what is actually going to do the validation and the applying of the configuration. And it's important to understand that because this runs under the context of the system account. It's actually the same WMI provider service that runs all your PowerShell sessions, that does all your own WMI calls. It's all under that context. And so when you start dealing with defining file and archive resources where you might have to pull from a UNC path to grab a zip file and deploy it to a server, it's going to be reaching out under the context of the system account, and so you have to worry about your permissions in that sense. A lot of the built-in resources do have a credentials property, so you can provide an alternate set of credentials to do this. Again, plain text passwords, probably a good reason to use group managed service accounts. Not that I've tried using them with this yet. But again, I'm hoping once this goes general availability in October, we'll start to see newer documentation, more comprehensive documentation, and some examples on how to do passwords properly without storing them in plain text, because I sure don't want to be encouraging that. By default, you have to be an administrator of the target server to give it a configuration. So in the push model, obviously you're going to have to be an admin where you're pushing to. That makes a good situation for the pull model, where you could then start to define restricted permissions on, say, the file share or the web server where those MOF files live, and so you can delegate administration capability without giving everyone local admin on the servers. I'm not sure if that's adjustable for the push model. And yep, clean install starts off as a push model. Two modes of the pull model, which I've hinted at. One is file share, another one's a web service. When you start dealing with custom resources, they're implemented as PowerShell modules, and when the local configuration manager is applying a configuration on the local machine, it needs that custom resource implementation locally to be able to implement it. If you're using the push model, you're going to have to push those custom resources out to all the machines yourself. Now that might be by starting your configuration with a file or an archive resource to go and grab those custom modules and push them out first and then refer to them later. Or you can switch to the pull model, which has built-in capability for going and locating the resources that are missing from the target machine, installing them, and then using them in the configuration. One thing that's also important to note is that when you run a configuration command, you're producing a single MOF file for each node in that configuration. And then the local configuration manager will only apply and validate a single MOF file per server at any one time. So if you then have a different configuration block which you run and generate a second MOF file, go apply that to the server. That'll then be applied to that server, and the old MOF file won't necessarily be reverted unless there's some sort of conflict between them that says this one says add, this one says take. But it means if you're subsequently doing any kind of checks against configuration drift, it's not going to pick up the old MOF file. But what I have seen, just from playing around, is it looks like you can have nested configurations. So you can have a global parent configuration that refers to another configuration, and then that'll then produce an Uber MOF file to define that server. So there's a modularization there, so it should be completely manageable. Cool, time for demo. Coincidentally, that happens to be command on the demo. To start a push mode. There we go. Alright. So a lot of this was learning DSC, fighting with it a bit, poking around inside the source code to try and work out how things are supposed to work. And so I guess my demo is a little bit anemic. It's just showing the bare bones of how it all works. I guess I was focused more on going sort of deep into how it all fits together, rather than, hey look, I can deploy an entire domain with a website in SQLbox. That obviously being the end goal. But we'll see how we're going here. Might take a bit of a risk here. See if I can switch my monitor setup. Does it work? No? Alright. I'm turning my head to the side. Hold on. Alright, so what I've got here is a configuration which has two resources in it. One is to install the Telnet client, actually a few resources, I forgot, and then 3 log messages. And what we've got here is Coincidentally, I happen to have ordered them in the file in the order I want them to execute, but DSC is going to parallelize as much as it can when it's applying the configuration. So I've actually got, the log message depends on the log before, and so log before happened, and then log message, and then log after. And none of them depend on or have any relationship with the Windows feature, so that'll happen in parallel. And you'll also note that I define a parameter log message up here, and then that'll get used in this text here. So what I'll do, so what I should now have is just the definition of this phrase. I might just step outside the demo box for a moment and just verify that. Cool. So I've got that command now defined, and as you can see there's a command type configuration. And the next thing I'm going to do is execute that command. I'm going to pass in that parameter that I defined, convert it to mof at substitute date here. Cool. Worked, produced a file in the subfolder where I'm currently at, and the file named after the node. And we'll just have a quick look at that result there. And font size, no, scroller doesn't work.
Zoom it.
Yeah. So that's enough. Cool. The important part is, so I go down to message, is we've got my translated time in there. So these parameters are evaluated at the time that I've generated the mof file, not at the time I applied the configuration to the target server. That was the key point of that. Yeah, awesome. I'm just going to turn on the normally disabled analytic event log for DSC so that we can have a look at what comes out later. And finally, the interesting bit, I'm going to start the DSC configuration. I'm going to tell it to use the mof files that are in that folder. I'm going to tell it to wait and to be verbose. And the reason why I'm doing that is because out of the box, start DSC configuration returns immediately with a job, standard PowerShell job. So you can then go and interrogate that later when it's done. By doing it this way, it's going to wait until it's actually completed applying the configuration before it returns, and the verbose is going to actually give us a chance to have a look at a little bit what's going on. Cool. So all this part's pretty quick. Let's come back up to the top. I don't want to dwell on this too much. The idea is that they've tried to make it as easy to understand what's going on as possible. And the word Jeffrey Snover used, who's responsible for PowerShell as a product even existing, was that you should be able to recognize what's happening, not read it, but just recognize. And so they've tried to make it very easy to instantly see what's going on. So what's happening here is it's testing whether the terminal client is there by using the get Windows feature. And then it decided to do install because it wasn't there. And then it started doing the logs, and we can see that we've logged out the message that I wrote into that mof file at the time I generated it. It hasn't changed. We're now 3 minutes later. Cool, and overall it took about 7 seconds to do that. And with any luck, we can have a quick look at what ended up in the analytic log. Should be about. I can't change the font size on this, don't ask. It's basically exactly what was on the screen before, but you can look at this if you run it as a job after the fact. Cool. I'll just do a little tidy up and then we'll Okay, so I've just applied a configuration. The local configuration manager has made that happen, and it's going to store that configuration away for later. And if I just use the test configuration, it's going to have a look at what the current configuration is supposed to be, compare that to what the system is, and go, cool, the telnet client's there, it's good. And I can confirm that by doing get DSC configuration as well. I get slightly more information than true. I get to see what it thinks the configuration is right now, and yes, telnet client, and it's present, and nothing exciting. Just to mess it up, I'm just going to uninstall that. There's a reason why I chose such a simple example, because I can just mess with it so easily and not have to wait for too long. Now we test it again. It's recognised that the current configuration of the server does not match your desired configuration because you've gone and uninstalled something, so the test configuration is false. If we get the configuration, important to note that it doesn't tell you what the configuration is supposed to be, it tells you what it is now. You'd have to go and inspect the MOF file yourself at the moment to find out what it's supposed to be. And you can see that it's now absent. And I can just tell it to restore it back to whatever it's supposed to be. You might think at this point that that restore configuration command would be really good to just go and jam into a scheduled task, maybe set it to run every 30 minutes, and then anytime someone touches something on the server they shouldn't, have it put it back. You don't have to, because the local configuration manager does that for you.
Can I ask a question?
Certainly can.
So how does it determine the kernel client is there? Is it making a WMI call? Is it looking at the executables?
In this particular instance, it's using the underlying Windows feature command. It's get Windows feature, install Windows feature, which under the hood go and use DISM. But the whole idea is that the implementation of each individual resource type abstracts away how. I've raised a request with Microsoft to have them fix that so that it would use another set of commands that do work on client OS, and when it detects that. But it's exactly that situation where you could have a custom resource for a client OS Windows feature which uses WMI to go and do that. And the whole point is it's not the problem of the way you declare your configuration of what you want it to be. I want this to happen, and it deals with the details.
Question. Can you use PowerShell to take a snapshot of the configuration?
I haven't seen anything that does that yet. This comes a little bit back to, I guess, a problem I have with DSC and a lot of solutions in general about the idea of the negative space. There's one aspect saying I've got a system configured the way I want. Let's turn that into a configuration file to use. But there's also the aspect of my configuration file describes the features that I want to be present. But it doesn't say anything about all the other features that are possible, which I might want to imply that should all be absent. And it doesn't deal with that scenario either. I think there might be a sort of combined situation there. At this point, I think someone would have to go and develop a solution that would be specific to each resource. So you might talk about the Windows feature resource and say, I want to generate a configuration definition for the installed Windows features on this box, and it would go and call get Windows feature and spit out the necessary PowerShell or MOF file to represent that, but it's not in the box. And again, something that Microsoft is sort of positioning this as is it's not necessarily an end product to use, but it is a platform on which everything else can then be built to use it. Things like System Center, things like Chef and Puppet, that already have a lot of really great tooling over the top of this, to then just leverage this to provide the implementation side of the Windows world, and in such a way that it's baked into the system. So yeah, hopefully all that sort of tooling will come elsewhere. Where did I get to? I restored the configuration. Cool. So we should be able to quick check on that. And it should tell us that true. Yep. And it's back. And so it's user pass. Yep. It's now back to good. It's now present again. And I call get Windows feature and goes, yep, it's definitely installed. So it's not lying to you there. So that was a really basic, here's a configuration, apply it for the first time, break it, put it back, verify it. That's that. So what's making this all work is the local configuration manager. And funnily enough, the local configuration manager can be configured. And it is configured through design state configuration. So nice little recursive scenario there. So at the moment, my local configuration manager, pretty much out of the box setup, bunch of properties on it. Hopefully you can see them. The important one's there. Bottom one, refresh mode is push at the moment, so it's the only one that's going to get configuration. A few other ones there. Obviously refresh mode can become pull. Configuration mode is currently apply and monitor. That can also become, what else? Apply and auto correct. I think also it's just monitor. I've got that written on the next script, I think. And obviously the frequency at which it'll do that, so that's in the background creating that scheduled task to settle that up. The credential, which is presumably what it will use to access remote resources. The certificate ID in there I mentioned before, which I haven't worked out how to use for encrypting passwords yet. And the download manager, which I've currently got this one configured to use a file share download manager if I turn it into pull mode, which actually I'll hopefully do at the moment. I've got two tabs here. Cool. So if I want to configure the local configuration manager, I just define a configuration document, just like any other ones. This one doesn't have a node though. It just has the local configuration manager resource, and it doesn't need a name because there's only ever one of them. And so I've got all of these properties already set up here. But there's the other two, apply only, apply and autocorrect. So I'm going to, in this case, I'm going to set it to pull mode. I'm going to tell it to go and pull from a particular file share, something I prepared earlier. It uses goods to access its files when it uses the pull mode model. And you can just give it any old GUID you want. When you set up pull mode for the first time, just give it a machine GUID and you know what file to create those files. In this case, I'm telling it to use the system GUID. I have no idea where it gets this from or how you would find out until it tries to pull the config. Hopefully this is something that Microsoft will reveal in the coming weeks. So, yeah, let's just apply. Cool. I just ran it really quickly and it spit out another moff file. In this case, it's a meta moff, slightly different, but essentially the same thing. And give you another look at that. Same as the last one, just different set of properties in it.
So you've defined where this node is going to pull its configuration.
Yeah.
So is there the concept of slaves and master here, or like potentially I can define heaps of different locations where I get my main configuration, and then I define this node will get its configuration from this, from there, this other node will.
At the moment, you give each machine one download manager. And that download manager knows how to go and find the configuration for that machine. There are two download managers that are shipped with the OS. One knows to go and look on a file share and look for a file of a particular name and check the hash on the file beside it and pull down modules from the directory next to it. There's also a web service download manager in the box which knows to go and hit a web server using OData service endpoints and basically do the same thing. Extending that model, there's no reason why you couldn't have a third type of download manager which enables you to have chains of configuration stores. So you'd have, a local configuration store that all the machines on the network segment would hit, and that one would then know how to pull more from a central one, so you could configure the master-slave arrangement. Out of the box right now, it's fairly basic.
So it's really low level. So you really need to you can do whatever you want, but it's your responsibility to set that up and see what fits your requirements.
If we have time at the end, there's a video that I'd like to show. When Microsoft released all this and announced it at Tech 8, they also did a presentation where the Chef guys have already built in support for this into their model. So use your existing Chef tooling to deploy your Linux systems. It'll now, through the same recipe model, allow you to embed a little piece of PowerShell configuration DSL and it'll go and generate the MOF files and use the configuration manager to apply that on Windows boxes. And so that really comes back to the whole idea that, yeah, this is reasonably low level, and then, you know, have existing tooling in the community build on top of that to provide an end-to-end suite. So I showed you the meta MOF, but I'm going to generate a file. I'm going to apply that configuration now. Cool, it's applied, and I'll prove it, just in case you haven't built up enough trust. Yeah. Hey, fresh mode pull. Well, you'd probably all like to see that do the pull, but I think my demo is going okay so far. I'm not going to push it too far. One of the important things with the file share based manager is it does, as well as look for the MOF file in the file share, it also looks for a checksum file right next to it. And I'm just going to demonstrate that they've included a get file hash command in the desired state module to enable you to easily get that stuff set up. I'm not sure if that's the intended use. Again, no documentation there. It supports a whole bunch of algorithms. It does SHA-1 by default, which might be okay. Probably not for much longer. So you just go and generate those hashes, and then a little bit of terse PowerShell there to go and stick it in a file with the checksum extension right next to it. I won't bore you with that too much. Here's the interesting parts. I've alluded to a couple of times. These are the two scheduled tasks that the local configuration manager sets up. They're basically set up to run on the schedule as per the configuration frequency in the settings. And all it's doing, whenever it runs, is spinning up PowerShell and going and hitting a method on the desired state configuration service to check the configuration and do whatever it needs to do, tell you if it's broken, fix it if that's the setting you've chosen. And so you can just go and grab that and run that whenever you want, if you want to do on-demand refresh of your boxes. And it's all based on SIMs. You can easily do it across 100 machines over HTTPS, very firewall friendly, very multi-machine friendly. I think we're getting towards some of the boring stuff. I kind of feel like I'm going on for a while. Does anyone else feel that this is maybe taking too long?
Have you worked out the telnet MOF now?
That is a really good question. Let's find out. Let's not do that. No. So it's in pull mode now, but it's still got the leftover push MOF there. Presumably, if it goes to the file share and finds a new MOF file that matches this node, it'll pull that one down within the 15-minute whatever frequency it's set to and apply that. Until then, presumably the old MOF file is going to be there. And one of the problems I had preparing for this demo is I couldn't for the life of me find out clear the DSC configuration command to say, pretending that I've never done a configuration ever. So I don't know if that questions that hopefully will all get answered once they decide to start talking to us because it's officially released. But yeah, this is just showing that under the System32 folder, new configuration folder, and this is where all the stuff is happening for where the MOF file goes when you apply configuration. And that's what we can go and compare it to. There's backups, there's the configuration there for the configuration manager itself. So that's your...
Sorry. Do you need to open any special port to allow communication between the nodes?
By default, server 2012 R2 has HTTP on port 5985 open by default. That's the standard PowerShell remoting port. And so from a clean install, you can remote in and configure DSC to work. For push mode, it's all using SIM, so I think it'll either be over the same port, maybe it will work over port 80 as well. It's all designed, it's all HTTP SOAP, so it'll either be port 80, 443 SSL, or I think it's the 5985, 5986 pair. It varies from OS version to OS version. It's been a while since I've kept on top of it. Older OSs, I think on a domain joined NIC, it'll automatically open the ports to manage this stuff, but on a NIC that's configured as public or private, it'll all be locked down. Don't know off the top of my head, for sure. A couple other useful commandments. There is the get resource, the DSC resource commandment. This will look at all the modules on the box and find which modules and implement resources and tell you a list of resources that are available to use in the configuration. So we should just get the standard 12 here. Actually, we'll get a few others. And I think this is how I discovered that you can actually start doing composite resources, because all the demo scripts configurations I've been using are actually showing up as resources now. So I anticipate that I could use those as node resources within a parent configuration. And then it gets really useful, because especially right now while the documentation online is out of date and regularly wrong, is you can actually ask for the syntax. And because PowerShell is all about the metadata and everything being self-describing, it'll just tell me this was really handy. It's not very fast. Anyway, so yeah, this is telling me that a user takes a name and has the username and depends on and all this stuff. All your sort of favourite things you expect to have in a user. And
It's coming up for an hour.
alright,
How much to go, you reckon?
I'm pretty close to done.
Alright, cool.
I'm gonna whip through this one. I've got a configuration here, which defines two node types. I've got a node which applies to all nodes, where I'm going to make sure the telnet client is present, and I'm going to log that I installed the telnet client. And I'm going to log a log message, which has come from some property on some node object. And I'm going to have another node which only applies to nodes in the role of web. And on these boxes, it's going to make sure that the web server Windows feature is present. And that's all I've done. And then a little bit later, I've defined, and this would be in a separate file in a separate place, potentially multiple variants of it, a hash table that says I have a set of rules that apply to all nodes. So, yep, so that message for all nodes. Just for interest's sake, that's the value you set if you really, really want to do passwords in plain text. Forget it now. You don't need to know that. And then I'm saying, I've got this one box that I'm on now here, the DevOps DSC machine, which is a pool server. And I've got another node, which is the DevOps web machine. If I'm feeling that's not going to work, so just quickly do some fixing. And that's going to define this machine as a web server. I'm not going to have multiple of those. And then when I generate the MOF file, I do so by passing that hash table in. And so I can have my one configuration that says, you know, all pool servers work like this, all servers have this, all web servers have these things. Then I have a separate thing that says, in my UAT environment, these are the two web servers, this is the one DSC server, this is the client box, and then I have another for production that says there's 4 web servers. And I just run the command twice, passing each of the 2 inputs in, and get 2 sets of MOF files out, one that I can put in the file share that applies to the UAT environment, one that applies to the file share to the prod environment. And all that's different is, you've got different server names, there's a different number of them, but the way they're configured, the things they have installed, the registry keys, the users, whatever, are all going to be consistent. And when you make that change to the overall template, you can then push that out to all the environments consistently. At least that's how it's supposed to work. Let's see if I got this right. Generate the MOF file, boom, okay, didn't like that. And I've got a feeling I know why. Yep. Excuse me. So I didn't have to scroll up and down each time. No, and so at this point I'm going to go, not getting that demo. But what I will do is I'll go back to the slides. And in the slides. No. There's nothing on how to set this up at all. I ended up poking around inside the source code for a little bit, trying to reverse engineer it, and ultimately gave up. But I can see how it's supposed to fit together. It's just a lot of guesswork. So I'm going to wait until Microsoft says this is the right way and stop guessing. Interestingly enough, this won't be in server core. You have to run a full server install to get that server to turn on. I presume it's because of the IIS dependency that it runs in. And of course, yeah, you might want to use it because then you don't have to have file shares and open up your TCP 445, all that sort of stuff. Custom DSC providers. Basically, when you write a script resource, which I didn't really cover, you write a get, a set, and a test function. Get tells DSC what the current state is. Test returns yes or no if it's working for that particular resource. And set goes and applies it if it needs to. You basically take those, make them 3 distinct functions, jam them in a module, and you define a MOF schema file which just says these are the properties that this resource can have, and these are the ones that are the primary key essentially. And yeah, you've got a custom resource. Actually pretty easy. And there's already a bunch out there. There's one for doing your DHCP service, setting up scopes. There's one for setting up your host file, not that you ever want to do that. Just have a DNS server done. And annoyingly, there's one in the Microsoft provided hands-on labs for provisioning IIS websites and setting up application pools and bindings and all that sort of stuff. It's not available anywhere. You have to go and OCR it out of the hands-on labs. I might post that soon.
5 minutes.
5 minutes, easy. But basically, if you're going to start using this as an early adopter, expect to write custom resources. There's 12 in the box, but they're basic. You're either going to be waiting until the community gets this stuff out there, or Microsoft does another round of development, or you're going to be writing these. So it's not so bad. The examples are easy to follow. I know I'm going to be writing a bunch. System Center kind of feels like a little of this DSC stuff overlaps with, say, System Center Configuration Manager. The official word from Microsoft, this is almost verbatim, the Configuration Manager is expected to be used by the enterprise, and desired state configuration is expected to be used in Azure and for DevOps. The Azure part's cool because the Azure virtual machine roles actually let you plug in a DSC configuration, and it will use that to provision the rest of the Azure VM. But I really think that that's very much it's trying to suggest that there's a mutual exclusivity between enterprise and DevOps, which I totally disagree with. But at the end of the day, I guess that's a problem for Microsoft's marketing to position Configuration Manager as something other than a Dev product. And Virtual Machine Manager 2012 R2, it'll call DSC configurations as part of the provisioning. So that's handy. Funnily enough, as a result of DSC and having declared syntax and MOF files, Windows becomes text files again. Just like Chef and Puppet and whatever try to treat it as. So it kind of works. And then of course you get the benefits. You can stick them in source control, you can search them, you get an audit trail, and if you use comments appropriately, they're kind of self-documented. I think, last slide. What do you do now? Basically, you follow the same principles, and I know I have, and a number of colleagues have, at various projects and clients, where you write all your scripts so that rather than just installing something, and then hoping that it's not there. You invite them to go, is it there yet? If not, install it. Otherwise, cool. Or, you know, I want this website to be bound to port 80. Is it bound to port 80? No. Add port 80. Otherwise, move on. Get your intent out of your implementation. So those sort of, if this, do it, otherwise don't, refactor that out into separate functions and separate modules. So you can just say, hey, I want a website, it should look like this in your main script, and let that underlying function do the implementation. And pull your environment configuration out as well. So, you know, if you've got UAT and prod, whatever you do, you know, call the script with different parameters, have a hash table somewhere, XML file, whatever. And what you find, and what I've found, is that a lot of what you'll be building, whether it is PowerShell or any other automation framework, is will start to fall out into basically what Microsoft has produced as what is the DSC product now. And then you're in a really good position to make that transition. If you choose certain keywords and syntaxes that align heavily with how DSC looks, it's going to make it even easier. But just having those separations of concern is going to fit nicely. And thank you for listening. I know I probably dragged on a bit, but I appreciate it. Hope you learned something.